Hello friends, welcome back. In the previous tutorials, we understood that a situation that is unwelcome is known as a problem. As in our day-to-day life, while developing softwares also, we come across variety of situations that are unwelcome or problems that we need to deal with and overcome. A process of arriving at an efficient solution to the given problem is known as problem solving. As computer has no self-intelligence, we need to guide the computer how to solve a problem by providing a set of well-defined steps or instructions or commands. To solve problems by using computer, we need to follow some well-defined steps. First, we need to understand and analyze the problem itself, and then we need to design various solutions by using an appropriate problem-solving tool. There are various problem-solving tools we have which help us to design solutions. They are algorithm, pseudocode, flowcharts, DFD, UMLs. Algorithm, pseudocode, flowcharts normally we find in structured-oriented programming languages or procedure-oriented programming languages to represent logics. We find algorithm, pseudocode, flowcharts, DFD, UML in complex application development which involve object-oriented concepts. We understood that algorithm is a step-by-step procedure to solve a specific problem. Algorithm contains natural language statements that it contains a set of precise and well-defined instructions. Whereas if you come to pseudocode, pseudocode is a minimized version of an algorithm. It is quite similar to a program but not a program. Algorithm contains set of well-defined statements or instructions, whereas pseudocode contains words, phrases, mathematical expressions. A good algorithm should be definite, correct, finite, and efficient. Algorithm can be easily translated to pseudocode, to a flowchart, or to a program. Similarly, pseudocode can also be translated to a flowchart, to a program directly. But algorithm and flowcharts have no visual representation, no graphical representation. Hence, to represent algorithms and pseudocodes graphically, we use flowcharts. What is a flowchart? Flowchart is a graphical representation of an algorithm or a pseudocode. It is used to graphically represent flow of program execution. Flowcharts we use to represent the flow of execution of a program. Each command or instruction or a statement is placed within a proper available graphical shape. Flowchart has various geometrical shapes in which we put statements. Oval shape is used to indicate start and end of the program logic. Parallelogram shape is used to indicate the input and output operations. Rectangle shape is used to indicate operations like declaring variables, assignment statements, expression statements, etc. Diamond shape indicates the decision operation. We write conditions within the diamond shapes. Hexagon shape indicates loops, iterations, or repetitions. If there are any loops in the program logic, we write that in hexagonal shape. Arrows indicates the direction or flow of execution of the program logic. If flowchart spreads to more than one page, then the circle shape is used to indicate the connection between them. Here I have an example for a flowchart. We understood how to write an algorithm, how to write a pseudocode, or how to translate an algorithm to a pseudocode. You can see algorithm contains well-defined instructions, whereas pseudocode contains words, phrases, mathematical expressions. We can translate an algorithm to a flowchart, or we can translate an algorithm to a pseudocode directly. We can translate a pseudocode to a flowchart. Here we have an example how to translate a pseudocode to a flowchart. You can see in the oval shape I have written the start keyword. We know that oval shape indicates the start of the program logic. Oval shape is used to indicate the start of the program logic. Next, we have written dim num1, dim num2, dim sum in rectangle boxes. We know that rectangle shape is used to indicate the operations like declaring variables. So here we have declared variables and we written those statements in rectangle boxes. Similarly, we have written num1 equal to 10, num2 equal to 10 in rectangle box because rectangle shape is used to indicate the operation like assignment. Also it is used to write the expressions. You can see that we have sum equal to num1 plus num2 written in a rectangle shape that indicates an expression. Parallelogram shape is used to indicate the input and output operations. You can see that we have written here print sum. That is actually an output operation we written in the parallelogram. And at the end, in the oval shape, we have written stop. We know that oval shape indicates the end of the program with respect to flowcharts. Now we know how to draw a flowchart, or how to translate an algorithm to a flowchart, or how to translate a pseudocode to a flowchart. And also you can see the arrow mark indicates the flow of execution of the program logic. We know that first this statement will get executed, then this statement will get executed, then this statement will get executed, then this statement will execute, then this statement will get executed, then this statement will get executed, then this statement will get executed, like this from top to down. So arrow mark indicates the flow of execution of the program logic that you should keep in your mind. Now we discuss some benefits of flowcharts. Flowchart helps us to visually communicate the logic of a system in an effective manner to the target audience. Flowchart helps us to analyze the problem efficiently. Flowchart work like a blueprint while developing a program. That means we write algorithms first, then we translate the algorithm to a pseudocode, then we translate the pseudocode to a flowchart, and we use that flowchart as a blueprint to write the program itself in a specific programming language while developing an application. There are some limitations with respect to flowchart, like if program logic is complex, then the flowchart becomes complex and clumsy. If a flowchart is very complex, then it is very difficult to draw also. If alterations need to be done to a flowchart, then we might need to redraw the entire flowchart once again. It is very difficult to redraw once again the flowchart. Also, flowchart cannot be simply typed. We need some graphics editing softwares like MS Paint, Photoshop, which allow us to draw diagrams. Hope you guys have understood what is a flowchart. So flowchart is a graphical representation of an algorithm or a pseudocode. Flowchart has some set of symbols. Flowchart is a blueprint, you can say. In the upcoming video tutorials, we discuss more on algorithm, pseudocode, flowcharts, UML, DFDs, step by step as and when we need them. As this is just an introduction to flowchart, I just wanted to give you a brief about flowchart. Hope you guys have understood clearly. For this tutorial, this much is enough, friends. For more benefits, please subscribe. Don't forget to like, comment and share these videos with others so that everyone will get benefited. Keep learning, keep coding, keep sharing. Thank you guys. Thank you very much.